Hello and welcome to Science Night Tales. I am glad you have found this quiet moment to ground yourself. Tonight, we are going to step into the woods. We often think of forests as peaceful places, static backdrops for a walk or a hike. But that is an illusion of time. We are going to look closer, peeling back the layers from the highest canopy to the deepest roots. We will see that a forest is not just a collection of trees, but a slow-motion explosion of energy, a biological machine that has been running without pause for thousands of years. You do not need to understand botany tonight. You are safe to observe from a distance. You can simply let the rhythm of the forest wash over you. If this perspective helps you find calm in nature's complexity, you are welcome to like or subscribe. For now, let go of the rush and let's enter the quiet woods together. Most people think they know what a forest is. They walk beneath trees. They follow a path. They hear leaves shift above them, and that feels complete. But that completeness is a distortion of scale. You see a forest as a place, a destination. But to the earth, a forest is not a place. It is a slow-motion explosion of energy. It is a biological machine that has been running for 10,000 years without a pause. Yet, we usually only catch a glimpse of a single frozen frame. What is usually experienced is only a narrow slice of something much larger. A surface view, a momentary contact. Forests are among the most complex ecosystems on Earth, not because they are mysterious, but because they operate across many layers at once, most of them unnoticed. What is visible is only the upper boundary of a system that extends upward, downward, and backward through time. Trunks and branches mark just one level. Leaves and needles mark another. Above them, light arrives unevenly. Below them, water moves slowly. Beneath that, soil stores centuries of change. A forest is not a fixed scene. It is a continuous process shaped by energy moving through matter. Sunlight, falling rain, dissolved minerals, shifting temperatures, all interacting quietly over long periods. At ground level, the details feel close and familiar. The texture of bark, the softness of soil underfoot, the pattern of shade moving across the forest floor. But this closeness can hide scale, because the forest is not only horizontal, it is vertical. From the highest leaves that first receive daylight to the deepest layers of soil that may not change for decades, the system spans many environments stacked in place. Each layer experiences the world differently. Light fades with height. Moisture increases near the ground. Temperature shifts by small but important degrees. What feels like one place is actually many overlapping zones. And time works differently in each one. Leaves form and fall within months. Branches grow across years. Trunks thicken across decades. Soil chemistry shifts across centuries. None of this requires observation. It continues regardless. The forest does not wait to be noticed. It does not speed up or slow down in response to attention. Its processes remain steady, governed by physical and chemical rules that do not change with presence. This steadiness is what allows complexity to accumulate. Layers build upon layers. Material is reused, rearranged, and redistributed. Energy enters, is transformed, and leaves again. From the outside, this can look still. From within, it is constant motion. water moves downward through leaves, branches, and soil. Carbon moves between air, wood, and ground. Nutrients cycle through roots, microbes, and organic matter. These movements are not dramatic. They do not announce themselves. They are slow enough to feel invisible. And yet, they define the system. Most human encounters with forests last minutes or hours, at most a season. But the forest operates on timescales that stretch far beyond that. Trees that appear mature may still be in early phases of their lifespan. Soil layers beneath them may predate the trees themselves. What seems stable is often transitional. What seems permanent is usually temporary. This is not instability, it is continuity. Change unfolds gradually, constrained by physical limits. Growth follows available energy. Decay follows availability of matter. Nothing here is wasted. Nothing disappears without re-entering the system in another form. From a distance, forests are often treated as scenery, a background, a setting. But they are not passive. They are not static. They are ongoing. Light enters at the top of the canopy. Some is absorbed immediately. Some passes through, scattered and reduced. By the time it reaches the forest floor, it carries only a fraction of its original intensity. That reduction shapes which plants can grow, how quickly they grow, and how energy moves through the rest of the system. Rain follows a similar path, intercepted by leaves, redirected by branches, filtered through layers before reaching the ground. Each delay matters. Each diversion shapes what comes next. Even the air behaves differently here. Movement slows near the ground. Humidity rises. Temperature extremes soften. These conditions create a local environment that is distinct from open land nearby. Not isolated, but moderated. All of this happens without coordination. No central control, no guiding intention. Just physical interactions repeating over time. The forest does not need to be understood to function. It does not require interpretation. It requires only energy input and material exchange. This is what makes it resilient, and also what makes it easy to overlook. Because nothing asks for attention. Nothing demands response. The system continues whether it is studied, walked through, or ignored. And because it continues slowly, it allows patience. There is no urgency here, no sudden shift required, no moment that must be captured. Observation can be gradual. Attention can settle. You do not need to search. You do not need to anticipate. Everything is already in motion. From the highest leaves responding to daily light cycles, to the deepest soil layers adjusting over decades, the forest holds many rhythms at once. Some are fast, some are slow, some are so gradual they feel still. Together, they form a single integrated system, not unified by purpose, but by shared constraints. Gravity pulls water downward. Diffusion moves gases between spaces. Chemical reactions follow temperature and concentration. These forces apply everywhere. The forest simply expresses them in layered form. Seen this way, the forest is not something entered, it is something encountered, briefly within its own timeline. And that perspective changes how it feels to be present. There is no need to hurry, no need to extract meaning. The forest does not build toward a conclusion. It does not move toward an endpoint. It remains open-ended, always adjusting, always continuing. From above, this system begins where light first touches leaves. That uppermost layer sets the conditions for everything below. And slowly, gently, attention can move there. Light reaches a forest before anything else does. It arrives from above, broad and unfocused at first, then gradually altered as it meets the uppermost leaves. Not all at once, not evenly. Some parts of the canopy receive direct sunlight for hours. Others remain in partial shade, catching light only as it shifts across the sky. This unevenness is the starting condition for everything that follows. Leaves intercept light based on their position, angle, and timing. A few centimeters of difference can change how much energy is available over the course of a day, over a season, over a year. There is no single canopy. There are layers within it. Upper leaves receive the strongest light and experience the widest temperature swings. Lower leaves operate under filtered conditions, responding to light that has already passed through other surfaces. Photosynthesis happens continuously here, not as a moment, not as a peak. It unfolds as long as light is present, limited only by availability of water, temperature, and carbon dioxide. When light increases, reaction rates adjust. When clouds pass, they slow. When seasons shift, the entire pattern recalibrates. Nothing switches on or off. Everything modulates. Leaves do not capture all incoming energy. Some light is reflected. Some passes through. Some is absorbed and transformed into chemical energy. This energy becomes structure, wood, fibers, stored compounds. The canopy is where most of the forest's energy enters the system. Not suddenly, not dramatically, just steadily, day after day. Air moves differently here than it does in open spaces. Branches slow wind. Leaves create friction. As airflow changes, so does temperature. Heat disperses more gradually. Cooling happens unevenly. Moisture lingers longer after rainfall. Evaporation slows beneath dense foliage. Water clings to surfaces, then drips downward in stages. Each pause alters timing. Each delay shapes distribution. The canopy does not seal the forest. It regulates it. Gases move in and out continuously. Oxygen released, carbon dioxide absorbed. The exchange is constant, balanced by diffusion rather than force. At this height, activity is dense but not chaotic. Growth follows availability. Spacing reflects competition for light, not conflict. Branches extend where light persists. They retract where it does not. Leaves form where energy return is sufficient to justify the structure that supports them. Where it is not, they are shed. Seasonal change reshapes this entire layer. In some forests, leaves thin or disappear entirely. In others, turnover is gradual and distributed across the year. Either way, light patterns change. So does energy flow. The canopy adjusts without urgency. It does not anticipate. It responds. Temperature variation is softened but not eliminated. Midday heat accumulates slowly. Nighttime cooling spreads gently. This moderation affects everything below. Rainfall arriving at the canopy is redirected. Some water never reaches the ground directly. It is intercepted, held briefly, then released. Drops fall at different intervals, different sizes, different locations. This redistribution reduces impact and spreads moisture across time. In this way, the canopy shapes not only energy input, but water delivery. Biological activity here reflects these conditions. Density increases where light is reliable. It thins where shade dominates. There is no fixed arrangement, only ongoing adjustment. Leaves age and are replaced. Branches shift their orientation over years. Entire crowns slowly change shape. These changes are subtle, easy to miss from one visit to the next, but over long periods, they alter how the forest receives energy. Most of the light entering the canopy does not continue unchanged. By the time it moves downward, it has been reduced, scattered, and filtered. Only a fraction reaches lower levels directly. That reduction is not a loss, it is redistribution. Energy is converted before it travels further. Stored, used, released again as heat. The canopy acts as the first stage in a long sequence. From here, what remains moves downward, gradually, quietly. And as it does, the environment below begins, under conditions already shaped by what happened above. Beneath the canopy, light changes character. It is still present, but it no longer arrives directly. Sunlight reaches the understory after passing through many surfaces. Leaves, branches, small gaps that open and close as the day moves on. What remains is softer, broken into fragments, distributed across time rather than space. Illumination here is measured in moments. A narrow beam that touches the forest floor, then moves on. A brief brightening as clouds shift overhead. A dim, steady glow that persists without direction. This filtered light defines the understory. Temperatures stabilize quickly at this level. The canopy above slows both heating and cooling. Daytime warmth accumulates gradually. Nighttime cooling settles without sharp drops. Wind loses its strength as it descends. Airflow becomes slower, less directional. Small currents form around trunks and shrubs, then dissolve. Movement exists, but it no longer dominates conditions. Moisture remains longer here. After rainfall, water lingers on leaves and soil surfaces. Evaporation slows. The environment becomes more consistent. Not static, but predictable. Plants that grow in the understory are shaped by these limits. They do not compete for height in the same way. Vertical growth offers diminishing returns. Light is not concentrated above, but scattered around. Instead, growth spreads outward. Leaves widen, surfaces increase. Shade tolerance replaces speed as the primary strategy. Energy intake is slower but steadier. Photosynthesis continues at lower rates for longer periods. Efficiency matters more than volume. Resources are used carefully. Structures are built to last. Some plants remain in this layer for decades without dramatic change. They persist rather than expand. Their growth patterns reflect long-term balance, not opportunity. Leaf turnover is slower. Stems are reinforced gradually. Repair happens continuously. Nothing rushes. The understory is not empty. It is occupied differently. Insects move through this layer constantly, not as events, as circulation. They process material, transfer energy, convert plant matter into forms that continue downward. Fungi spread through soil and organic debris. They break down fallen leaves and wood, releasing nutrients slowly. This work does not peak. It proceeds at a steady pace, regulated by moisture and temperature rather than season alone. Small animals pass through quietly. Their movement redistributes matter more than it alters structure. Seeds are carried, waste is deposited, soil is disturbed in minor ways. Each action contributes without drawing attention. Nothing here operates in isolation. Processes overlap. Growth depends on what filters down from above. Decomposition feeds what remains rooted below. Light sets the rhythm, not intensity. Duration. Plants respond to how long light remains usable, not how bright it becomes. A few additional minutes of low light can matter more than a brief flare of brightness. This sensitivity shapes form and spacing. Leaves are arranged to avoid overlapping too much. Gaps are maintained where possible. Competition exists, but it unfolds slowly. When a canopy opening forms above, conditions shift gently rather than suddenly. Light increases incrementally. Temperatures adjust over days. The understory responds in stages. Growth rates change. Leaf production adjusts. Nothing surges. This layer absorbs change without amplification. Sound is muted here. Movement is restrained. The forest feels closer, not because it is smaller, but because transitions are gradual. From this level, the ground is never far away, but it is not the focus yet. Most energy here is still moving, downward, outward, into storage. Material accumulates slowly. Organic matter settles. Nutrients concentrate near the surface. Over time, the understory becomes a bridge, not a boundary. It links what happens above with what happens below. As light continues to weaken, biological activity becomes less visible, not reduced, just quieter. The next shift is subtle, but it is consistent. Eventually, light no longer defines the system, and attention begins to move away from what grows upward toward what accumulates beneath. Light reaches the forest floor only indirectly now. What arrives has already been altered, slowed, filtered through many layers. Most of the energy that enters this level no longer supports growth. It supports processing. The ground is covered with material that once lived higher up. Leaves, small branches, fragments of bark. Occasionally, entire trunks that have fallen and remained where they landed. This layer does not change quickly. It accumulates. Each season adds a thin contribution, a scatter of leaves, a layer of needles, petals, seeds, fine wood. Nothing disappears all at once. Material settles into place and stays. Moisture is held close to the surface here. The canopy above reduces evaporation. Shade limits temperature swings. As a result, conditions remain stable for long periods. The forest floor stays cool through the day. At night, it releases heat slowly. Freezing and drying are rare events. These steady conditions allow chemical processes to proceed without interruption. Decomposition is not an event. It is a continuous adjustment. Organic material is broken down step by step.
Large structures are reduced gradually. Molecules are separated, rearranged, reused. Leaves soften first. Cell walls weaken. Nutrients become accessible again. Wood follows more slowly. Dense material resists change. Breakdown occurs over years, sometimes decades. Nothing vanishes. It changes form. Carbon remains present. Nitrogen is redistributed. Minerals return to circulation.
The forest floor functions as storage. Energy that entered the system months or years earlier is released in small increments. There are no peaks, no releases. The pace is controlled by moisture, temperature, and time. Movement is minimal. Most activity happens at scales too small to notice directly. Chemical reactions, microbial growth, gradual transfer of matter between states. Larger organisms pass through occasionally. They disturb the surface lightly, then move on. Their impact is brief. The ground quickly returns to its previous arrangement. Leaf litter layers compress under their own weight. Air spaces form and collapse. Water moves slowly downward. This process increases density without hardening the surface. The floor remains permeable, open to exchange. Oxygen penetrates shallow layers. Deeper zones become more stable, less reactive. As material accumulates, it insulates what lies beneath. Temperature fluctuations diminish further. Seasonal changes are softened. Winter cold reaches this layer late. Summer heat is muted. These conditions favor persistence. Nothing here needs to respond quickly. Seeds may remain dormant for long periods. Nutrients wait until they are taken up again. The system does not require constant attention. Time does the work. Fallen wood illustrates this pace clearly. A trunk that collapses onto the ground does not interrupt the forest. It becomes part of the surface. Moisture collects around it. Chemical breakdown begins at contact points. Outer layers soften first. Interior structure holds. Over years, density decreases. Material transfers to the surrounding soil. The shape remains recognizable long after function has ended. This slow change contributes to uniformity. The forest floor rarely experiences sudden transformation. Even storms leave only temporary marks. Branches fall, leaves scatter, but the underlying structure remains. Accumulation continues. As light diminishes further, visual complexity decreases. Colors shift toward browns and muted greens. Textures dominate. Surfaces become irregular but predictable. The ground absorbs sound. Movement is softened. Nothing calls attention to itself. At this level, continuity becomes the defining feature. Processes overlap and repeat, season after season. Material cycles without urgency. The forest floor does not mark beginnings or endings. It maintains balance. What arrives from above is accepted. What moves downward is passed along. There is no boundary here, only transition. Below this layer, conditions become even more stable. Light no longer influences structure at all. Temperature remains nearly constant. What matters next is not growth or decay, but persistence. And just beneath the surface, that persistence becomes measurable. Below the forest floor, conditions change again. Light no longer plays a role. Temperature varies only slightly. Moisture moves slowly. This region is structured, not empty. Soil forms in layers. Each layer has a different density, different mineral content, different capacity to hold water and air. The upper soil remains loose. It contains fine organic material mixed with mineral particles. Roots occupy much of this space. They spread gradually, not outward in bursts, but incrementally, responding to moisture and chemistry. Movement here is slow enough to feel absent. Roots extend millimeter by millimeter. They pause, they adjust direction. The soil accommodates this growth without disruption. Water moves downward through small pores. Gravity pulls it gently. Capillary action holds it in place. Nothing rushes. As depth increases, organic material becomes less concentrated. Mineral particles dominate. The structure becomes more compact. Change still occurs, but over longer intervals. Within this layered environment, exchange continues. Fungi occupy much of the space between particles. Their structures remain thin and widely distributed. They do not move quickly. They expand as conditions allow. These fungal connections form pathways, not for communication, but for transport. Nutrients dissolved in water move along gradients, from areas of higher concentration to lower ones. This movement does not require direction. It follows physical rules. Roots absorb what becomes available. Excess remains in circulation. The process repeats continuously. No signal marks the transfer. No moment announces it. Material shifts location gradually. Carbon compounds enter the soil through decaying matter. Nitrogen follows different pathways. Minerals dissolve and reattach. Each element moves according to its properties. The system remains balanced by constraint, not control. Pressure from above keeps the soil compacted. Water content stabilizes temperature. Seasonal effects diminish quickly with depth. At this level, winter and summer feel similar. The soil retains memory through composition, not form. Chemical traces remain long after surface conditions change. Past seasons contribute to present structure. Roots from previous growth cycles decompose in place. They leave channels behind. These channels alter water movement slightly. They persist until filled or collapsed. Change accumulates without replacement. The underground environment does not reset. It adapts by addition. Mycorrhizal structures follow existing paths. They do not create new space. They occupy what is already available. Their function remains constant. Transport, exchange, redistribution. Energy moves through chemistry here, not light. No single exchange matters more than another. The scale remains uniform. Time smooths variation. Activity remains below the threshold of perception. Nothing here responds to seconds or minutes. Hours matter little. Days blend together. Only long durations produce measurable shifts. The soil acts as a buffer. It absorbs change. It releases it slowly. Surface disturbances rarely reach this depth. Footsteps pass overhead unnoticed. Wind does not register. Even heavy rain becomes moderated as it moves downward. This stability allows processes to continue uninterrupted. Nutrients circulate without interruption. Water remains available. The system favors persistence. Depth increases consistency. Below the active root zone, change slows further. Material becomes older.
Organic input decreases, mineral layers dominate, movement becomes geological in pace, yet connection remains. What happens above eventually influences what lies below. It just takes time. Years pass before surface material reaches deeper layers. Decades pass before it is fully integrated. Nothing is lost, it is repositioned. The underground does not function as a hidden world. It functions as a reserve. It holds, it stores, it moderates. The forest above depends on this stability, even if it never encounters it directly. From this depth, biological activity no longer defines the system. Processes become less about growth and more about endurance. The rhythm slows further. Beyond this point, attention shifts away from living structures and toward the persistence of systems themselves. What remains is continuity, measured not in seasons, but in time.
What lies beneath the visible forest is not defined by speed. It is defined by duration. Soil does not appear all at once. It forms gradually. Fragments of rock break down under pressure and moisture. Organic material settles and mixes over long periods. Each layer records accumulation rather than events. Particles arrive slowly, they remain. Minerals weather through chemical interaction with water and air. The process continues whether or not anything above changes. Time shapes the soil without interruption. Centuries pass as texture develops, grain by grain. No single moment marks completion. The soil never finishes forming. It only continues. Roots interact with this structure continuously. They do not dominate it. They adjust to it. Root systems spread where conditions allow. They follow paths of least resistance. Water availability guides direction. Soil density limits extension. This interaction produces stability. Roots anchor loose material. They reduce erosion. They slow the movement of water through the ground. They hold particles in place. None of this requires activity to be noticeable. It occurs gradually. As roots age, they thicken. Some persist for decades. Others decay and leave channels behind. These channels alter future flow. They remain long after the original structure is gone. Stability accumulates. Nutrients move through soil slowly. They bind to particles. They release under specific conditions. The system balances retention and availability. Nothing is wasted. Nothing moves quickly. Carbon becomes part of the soil matrix. Nitrogen follows cycles shaped by moisture and chemistry. The pace remains steady. This environment favors persistence over change. Temperature remains buffered. Moisture varies within narrow limits. Extreme surface conditions do not reach this depth. The soil absorbs variation and releases it slowly. Roots rely on this predictability. They do not need constant adjustment. They respond to trends rather than fluctuations. Time here is not measured in growth spurts. It is measured in continuity. Years blend into one another. Decades pass without visible alteration. Yet structure continues to refine itself. Each season adds a small amount of material. Each cycle alters composition slightly. Accumulation replaces transformation. The forest depends on this slow process. Without it, stability above would not persist. Trunks remain upright because soil holds firm. Water remains available because it is retained below. Nothing about this requires constant motion. The system remains effective through consistency. Roots do not compete for speed. They occupy space as it becomes available. They adapt to constraints rather than overcoming them. This produces an environment that resists disruption. Storms pass overhead. Droughts alter surface conditions. Below, moisture changes slowly. Structure remains intact. Soil layers maintain their arrangement. Even when surface vegetation changes, subsurface structure persists. New growth builds upon existing foundations. Time becomes the primary organizing force. Processes repeat without accumulation of stress. Each cycle reinforces stability rather than eroding it. This persistence does not imply inactivity. Chemical reactions continue. Water moves. But the rate remains controlled. Nothing escalates. The forest floor above may appear dynamic. Leaves fall. Growth rises and fades. Below, continuity dominates. Roots interact with soil as part of an ongoing system. No individual root matters more than the structure as a whole. Stability emerges from repetition. Not repetition of motion, but repetition of conditions. Year after year, similar inputs produce similar outcomes. Small variations integrate without disruption. The soil remembers through composition. Past conditions remain embedded in structure. Older layers do not disappear. They support newer ones. Time accumulates downward. Depth increases age. At greater depths, material may be thousands of years old, yet it remains part of the same system. Roots from current growth still interact with this history. They draw nutrients shaped by long-term processes. This connection links present growth to past accumulation. Nothing here rushes toward an endpoint. The system does not seek completion. It maintains itself through balance. Roots reinforce soil. Soil supports roots. Water circulates. Minerals bind and release. Time governs all of it, not as an external factor, as an internal dimension. The forest exists not just in space, but across duration. Stability arises from this extended timeline. What appears still is simply slow. This understanding shifts attention from visible movement to underlying persistence, from growth to maintenance, from change to continuity. As this perspective settles, repetition becomes visible. Season after season passes above. Below, the system holds. And that feels complete. This quiet consistency prepares the way for another pattern. One shaped not only by time, but by cycles that return again and again. Stability does not mean stillness. In the forest, change continues, but it follows a rhythm that rarely surprises. Light shifts gradually over the course of a year. Day length increases, then decreases. The angle of sunlight changes slowly, almost imperceptibly. Nothing reacts all at once. Seasonal change enters the system quietly. In early spring, temperatures rise by small increments. Soil warms from the surface downward. Moisture remains stored from previous months. These conditions allow activity to resume where it paused. Not suddenly, not everywhere at the same time. Roots begin absorbing water more consistently.
Microorganisms increase metabolic activity within narrow limits. The system responds evenly. Spring does not signal urgency, it signals availability. Light becomes more frequent. Water becomes easier to access. Chemical reactions proceed with fewer constraints.
Processes that never stopped simply adjust their pace. Growth occurs where conditions support it. Elsewhere, systems remain unchanged. As weeks pass, spring blends into early summer. Daylight reaches its longest duration. Temperatures stabilize within a predictable range. The forest does not rush to take advantage of this period. It operates within limits set long before. Leaves maintain steady rates of photosynthesis. Roots continue regulated uptake of water and nutrients. Nothing pushes beyond capacity. Heat affects the uppermost layers of soil. Below the surface, temperature remains buffered. Moisture evaporates slowly. Rainfall replenishes it intermittently. The balance holds. Summer does not represent a peak. It represents consistency. Processes repeat daily without variation that requires adjustment. Energy enters the system at a regular rate. Energy leaves at a similar rate. Storage and release remain aligned. As the year progresses, subtle changes begin again. Daylight shortens gradually. Temperatures decrease by degrees, not shifts. Autumn introduces a change in input rather than activity. Leaves detach and accumulate on the forest floor. This material does not disrupt existing processes. It becomes part of ongoing cycles. Moisture levels fluctuate with rainfall. Decomposition responds proportionally. Chemical breakdown proceeds slowly. Nothing accelerates to accommodate this input. The system absorbs it without strain. Autumn does not represent decline. It represents redistribution. Materials move from one form to another. Energy transitions into storage. Roots reduce uptake slightly. Microbial activity adjusts to temperature changes. Still, processes continue. Winter arrives without a clear boundary. Temperatures drop gradually. Surface water movement slows. Above ground, visible activity decreases. Below ground, conditions remain stable. Soil retains heat accumulated over previous months. Moisture remains present. Medical reactions continue at slower rates. Roots remain in place. Microorganisms remain active within tolerance ranges. Nothing stops. Winter does not pause the system. It moderates it. Activity shifts inward and downward. Surface change does not penetrate deeply. Seasonal repetition reinforces structure. Each year follows a similar pattern. Small differences occur. Rainfall varies slightly. Temperatures fluctuate within known limits. These variations do not accumulate stress. They distribute it. Over time, repetition shapes expectation. Root systems develop in response to average conditions, not extremes. Soil composition reflects long-term input patterns, not individual seasons. Nutrient availability follows predictable cycles. The system does not prepare for singular events. It accommodates variation as routine. Spring does not demand acceleration. Summer does not require expansion. Autumn does not force contraction. Winter does not impose dormancy. Each phase blends into the next. The boundaries between seasons remain diffuse. No moment marks a clear transition. Change enters gradually and exits the same way.
This continuity reduces the need for reaction. Processes respond through adjustment, not interruption. Moisture increases, uptake adjusts. Temperature decreases, reaction rates slow. Nothing requires decision. Physical and chemical constraints guide response. Time operates here as repetition. Years stack gently on top of one another. A single year carries little weight. Its influence disperses across decades. Trees grow incrementally each season. Their structure reflects accumulated cycles. Ring by ring, growth records consistency more than variation. The forest does not respond to seasons as events. It incorporates them as background conditions. Seasonal change becomes predictable input. Predictability supports persistence. The system remains resilient because it does not rely on timing. Processes are not synchronized to specific moments. They operate within ranges. When conditions shift, activity shifts proportionally. No threshold triggers abrupt change. This approach to time minimizes disruption. Stress does not accumulate. Variation dissipates through repetition. Over long periods, patterns stabilize. Seasonal cycles repeat thousands of times. Each cycle contributes little on its own. Together, they define structure. Soil depth reflects centuries of accumulation. Root distribution reflects decades of moisture patterns. Canopy density reflects long-term light availability. Nothing depends on a single season. Everything depends on continuity. From this perspective, seasons lose urgency. They are not markers of progress, they are features of stability. The forest persists because change remains expected, because variation remains bounded, because time moves forward without pressure. This rhythm prepares the ground for longer scales, beyond years, beyond cycles that repeat visibly, toward changes that occur so slowly they appear motionless, processes that unfold across centuries and millennia. Seasonal repetition becomes a baseline, a steady pulse beneath deeper time. Change without demand, movement without disruption, continuity that does not need attention. And as attention settles into this rhythm, it becomes possible to sense how stability extends beyond seasons, beyond visible change, into durations that no longer register as cycles at all. Years repeat quietly in one place. As seasons cycle, something slower takes shape beneath them. Growth continues, but at a pace that resists notice. Trees add material in thin layers. Each year contributes a narrow band of tissue. Thickness accumulates gradually. A decade leaves a small trace. A century becomes measurable. From the outside, form appears unchanged. Height increases incrementally. Diameter expands by small margins. These changes are not visible day to day. They require time to register. Some trees persist through many human lifetimes. Their structure reflects conditions that no longer exist. Light levels from centuries ago, moisture patterns from earlier climates. The forest carries this information without display. You can stand in one location and observe organisms that began growing before modern records. They remain integrated into the same system. Replacement does not occur abruptly. When a tree declines, the process unfolds slowly. Water transport decreases gradually. Growth slows before stopping. Structural integrity weakens over long periods. Branches fall years before trunks fail. Openings appear in the canopy. Light reaches lower layers in narrow columns. This change does not disrupt the forest. It redistributes energy.
Seedlings respond to new light availability. Growth increases where conditions permit. Not all openings result in replacement. Some remain partial, others close slowly as surrounding growth expands. The system adjusts without coordination. No single organism directs this process. It unfolds through constraints and opportunity. Long-lived organisms coexist with shorter-lived ones. Mosses establish and persist in stable microclimates. Fungi extend networks that outlast individual plants. Insects complete many generations within the lifespan of a single tree. Each group operates on its own timescale. Their interactions overlap without synchronization. Disturbance occurs occasionally. Wind removes material, ice adds weight, rain alters soil structure. These events do not reset the system. They introduce variation. Recovery does not begin at a specific moment. Processes that were already in place continue under modified conditions. Soil remains intact. Roots persist. Microbial activity adjusts to new inputs. Decomposition increases where material accumulates. Regrowth follows availability, not urgency. Some areas recover quickly, others change slowly. The forest does not return to a previous state, it transitions. Structure reflects accumulated responses. Over centuries, composition shifts. Species proportions adjust gradually. No single change dominates. Incremental differences add up. One generation replaces another without clear boundaries. Seeds germinate where conditions support survival. Others remain dormant. Time filters outcomes without intervention. What remains reflects compatibility with long-term conditions. The forest becomes a record of persistence, not through memory, through structure. Each layer holds evidence of duration. Soil depth increases as organic matter accumulates. Root systems expand and overlap. Water pathways stabilize. These features form slowly. They remain once established. Long-lived organisms contribute stability. Their presence moderates environmental extremes. Shade regulates temperature. Roots stabilize moisture. This buffering supports continuity. Short-lived organisms operate within this framework. They cycle nutrients rapidly. They respond quickly to change. Together, they balance timescales. Fast processes occur within slow ones. Neither dominates. Over centuries, patterns emerge, not as events, as tendencies. Certain areas remain consistently moist, others dry. Growth reflects these patterns. The forest becomes heterogeneous. Variation persists without disorder. This variation supports resilience. When conditions shift slightly, responses distribute. No single pathway bears the full change. Long-term stability does not mean uniformity. It means accommodation. Change integrates rather than accumulates. Centuries pass without clear markers. No moment signals transition. The forest remains recognizable, yet it is never the same. Material moves through phases. Carbon shifts between forms. Minerals redistribute slowly. Water cycles through storage and release. These processes do not require attention. They continue regardless of observation. Human timescales intersect briefly. Paths appear and disappear. Clearings open and close. The forest absorbs these changes, not immediately, over decades. Structural adjustment smooths disturbance. Nothing rushes to restore balance. Balance emerges through duration. Trees that persist for centuries provide continuity. Their removal does not erase structure, it alters conditions. Successors establish gradually. The system adapts without memory of loss. There is no baseline to return to, only ongoing adjustment. From this perspective, change loses narrative. There is no beginning, no climax, no conclusion, only accumulation. Time deepens rather than advances. Processes overlap, outcomes distribute. The forest exists as a continuous state. Centuries pass as extensions of moments. Moments stack into structure. This duration creates context. It prepares the system for even larger scales, beyond individual organisms, beyond generations, toward continuity measured across landscapes and climates, where forests participate in processes larger than themselves, connected to systems that extend beyond any single place. And as attention rests on this extended timescale, it becomes easier to sense how one forest fits into patterns that operate far beyond its boundaries, across regions, across the planet, without interruption. A forest can be described without reference to any single organism. It can be understood as a long-term interaction between land, air, water, and energy. An arrangement that persists whether or not it is observed, named, or entered. Trees are visible, but they are not the system. Leaves fall, but the system remains. Individual trunks age and collapse, yet the underlying processes continue without interruption. At the scale of decades or centuries, the forest is less an environment of events than an environment of balances. Carbon moves slowly from the atmosphere into living tissue, then gradually into soil. Water arrives as precipitation, lingers in organic layers, seeps downward through mineral horizons, and eventually returns to rivers or the air. Nutrients circulate within narrow ranges, rarely lost entirely, more often delayed, stored, or redistributed. Energy enters as sunlight and exits as heat, diffused over time by vegetation, soil moisture, and surface roughness. None of these movements require speed. The forest moderates extremes not through reaction, but through capacity. Leaves intercept rainfall before it reaches the ground, reducing erosion and slowing runoff. Roots anchor soil, increasing infiltration and reducing sudden loss. Organic layers insulate the ground surface, buffering temperature changes that would otherwise penetrate deeply. These effects accumulate quietly, season after season, without dramatic markers. From above, the canopy appears as a textured surface interacting with the atmosphere. Wind slows as it passes through foliage. Moisture released from leaves alters humidity and local temperature gradients. The forest does not control weather, but it shapes the conditions under which weather unfolds. Over long periods, these interactions influence regional water cycles, cloud formation tendencies, and surface temperatures. The influence is diffuse, not centralized. At ground level, the forest's role becomes one of retention and mediation. Soil stores water during wet periods and releases it gradually during dry ones. Organic matter binds nutrients that would otherwise leach away. Microbial activity regulates chemical availability without sharp thresholds. Stability arises not from constancy, but from distributed adjustment across many small processes
operating simultaneously. The forest does not respond to change as a single unit. It absorbs variation by spreading it across layers, organisms, and timescales. When temperature patterns shift over years or decades, growth rates adjust incrementally. Species distributions change slowly, often through differences in recruitment rather than sudden disappearance. Some trees fail to reproduce, others establish more successfully.
The structure of the forest alters its proportions without abandoning its function. Canopy height, density, and composition may change, but the exchange of energy, water, and carbon continues. This persistence is not dependent on equilibrium in the strict sense. It depends on resilience through redundancy. Multiple species perform similar roles. Different root depths access water at different times. Varied leaf forms intercept light across changing angles and seasons. If one pathway becomes less effective, others compensate without requiring coordination or awareness. The forest remains operational because no single component is indispensable in isolation. From a planetary perspective, forests are part of Earth's surface system, interacting continuously with oceans, ice, and the atmosphere. They influence albedo by darkening the land surface. They participate in long-term carbon storage through soil formation. They affect hydrological cycles by regulating evapotranspiration and groundwater recharge. These contributions are not evenly distributed, nor are they synchronized. Each forest operates according to local conditions: latitude, elevation, soil type, and climate history. Yet collectively, forests form a broad, persistent interface between the solid Earth and the gaseous envelope above it. Over geological timescales, forests have expanded and contracted repeatedly. They have followed climate zones across continents. They have adapted to changing atmospheric compositions and solar output. Their presence today reflects not permanence, but continuity through adaptation. Even so, the processes occurring within a single forest are slow enough to feel stable from a human perspective. A tree growing 1 millimeter per year does not register urgency. Soil accumulating fractions of a millimeter over decades does not signal change. Carbon stored gradually in organic layers does not announce completion. These processes operate below the threshold of immediate perception, yet they define the long-term character of the landscape. Observation is not required for function. The forest continues its exchanges whether it is measured or ignored. It absorbs rainfall at night. It releases heat after sunset. It exchanges gases continuously with the surrounding air. Its rhythms are not synchronized to human schedules or awareness. In this sense, the forest is not an object, but a condition. It is a set of constraints and pathways that shape how matter and energy move across a region. Remove individual components, and the system adjusts. Alter conditions gradually, and the system reorganizes. What persists is not form, but process. The forest does not aim to maintain a specific appearance. It maintains relationships. Soil remains connected to roots. Roots remain connected to water. Water remains connected to atmosphere. These links do not require intention or acceleration. They endure through repetition and gradual change. From far above, Earth appears as a planet defined by circulation, winds, currents, and cycles that repeat with variation. Forests participate in this circulation without standing out as discrete units. They blend into the larger system, one of many surfaces modulating planetary flow. From within, the forest feels enclosed, detailed, and specific. But its persistence does not depend on proximity. It is shaped as much by distant forces, solar energy, orbital cycles, atmospheric composition, as by local interactions. Time operates differently at this scale. Years become units of adjustment rather than milestones. Centuries become measures of accumulation. The forest does not hurry toward an outcome. It remains open to continuation. Even disturbance fits within this framework. Fire, wind, and flood alter structure, but they do not negate process. Material is rearranged rather than erased. Nutrients return to soil. Space opens for different growth patterns. Over long periods, the forest absorbs these changes into its ongoing exchanges. Alternate does not mean resistance to change. It means continuity through change. At no point does the system pause. There is no final state to reach, no balance to lock in permanently. There is only sustained interaction across layers, scales, and durations. The forest exists not as a statement, but as a condition that continues. And within that condition, individual moments, seasons, growth spurts, quiet years pass without demanding recognition. The system remains, operating steadily, shaped by time rather than driven by events. Nothing here requires urgency. The forest does not need to be preserved in memory to persist in function. It does not depend on attention to continue its exchanges. It occupies its place within Earth's systems quietly, contributing through duration rather than intensity. Seen this way, the forest is not a scene, but a long-running process, one that extends beyond immediate experience and remains indifferent to observation. The forest does not gather itself into a final state. It continues as it has, through overlapping processes that do not align to moments or markers. Nutrients move slowly through soil, passing from decaying matter into water, from water into roots, from roots into wood and leaves, then back again. This movement has no visible beginning and no point of completion. It circulates quietly, guided by gradients rather than direction. Growth proceeds without emphasis. Cells divide, fibers thicken, rings form inside trunks, each one recording a season without announcing it. Some years add more material, others less, but none interrupt the sequence. What accumulates does so gradually, without drawing attention to the act of accumulation itself. The forest becomes what it is by remaining within these small, repeated changes. Decay unfolds alongside growth, not as an opposite, but as a parallel motion. Leaves fall, settle, soften, and fragment. Wood weakens, collapses inward, and becomes porous. Microorganisms convert structure into simpler compounds, releasing elements back into circulation. Nothing disappears. Matter only changes its arrangement, moving from one stable form into another, then another still. This exchange does not accelerate. It remains paced by temperature, moisture, and time. Chemical reactions proceed at rates set by conditions that have remained broadly consistent across generations. Even variation is absorbed gradually, smoothed into longer trends rather than expressed as abrupt shifts. Seasons repeat without urgency. Light angles change. Day length shortens and extends. Moisture patterns adjust. Activity increases and recedes, not as a signal, but as a response. Each cycle resembles the last closely enough that difference is difficult to isolate. The forest does not react, it adjusts, continuing within limits shaped by long familiarity. These repetitions do not require recognition. They proceed whether observed or unnoticed, whether named or left unmarked. The forest does not move toward a state of completion. It does not prepare for arrival. It remains distributed across time, with no single moment holding greater weight than another. Beneath the surface, processes continue at an even slower pace. Roots extend incrementally, responding to gradients of water and minerals. Fungal networks persist, maintaining connections that shift subtly over years rather than days. Soil layers change texture and composition as particles settle, bind, and reorganize. These movements are measured not in steps, but in persistence. Nothing signals transition. There is no threshold where one phase ends and another begins. Change is continuous enough that boundaries blur. What is present now differs slightly from what was present before, but not enough to require attention. Continuity absorbs difference. Time stretches without emphasis. Decades form quietly from seasons. Centuries emerge from repeated growth and loss, each cycle leaving faint traces rather than marks. The forest becomes older without aging in any visible way. It does not accumulate history as a narrative, only as structure. The system remains open. Energy enters gradually through light. Matter cycles locally, then disperses. Water moves downward, outward, upward again. Heat is absorbed, redistributed, released. These motions do not converge on an outcome. They maintain conditions within which continuation is possible. There is no need for intervention. The forest does not rely on observation, interpretation, or response. Its processes remain stable enough to persist, flexible enough to accommodate variation, quiet enough to pass unnoticed. As attention softens, nothing changes. Growth continues. Decay continues. Circulation continues. The system does not register the presence or absence of awareness. It does not accelerate or slow in response. It simply remains within its established rhythms. There is no final image to hold, only overlapping processes, moving at different speeds, layered in space and time. Some are visible, most are not. All proceed without urgency, without instruction, without conclusion. The forest does not close. It remains in motion that feels like stillness, in change that resembles rest. What has been described does not resolve into an ending. It continues outward, beyond the edge of focus, beyond this moment, unchanged by whether it is followed further or allowed to fade. And as the narration loosens, the system stays intact, persistent, balanced, and ongoing, continuing quietly, without need for an ending. We have returned from the deep layers of the forest, carrying the memory of its slow, steady pulse. We have seen that a forest does not need to rush to be powerful. It grows, it decays, and it persists, all at its own pace. The trees do not compete with time, they embody it. There is a deep peace in knowing that these systems continue without us. They do not need our attention, our permission, or our help to keep functioning. They simply are. Just as the forest holds itself together through balance and patience, you can trust in your own resilience. You can let your thoughts settle now. The roots are deep, the cycles are turning, and you are safe to rest. From all of us at Science Night Tales, thank you for drifting with us. The forest is steady. You are safe.